3-3, plate tectonics. This is where the ideas of continental drift and ocean floor spreading meet. So we're introducing this term lithosphere. The lithosphere is that's which has to do with land. Okay, so the Earth has the hydrosphere, which is our water, has the atmosphere, which is the air, and has the lithosphere, which has everything to do with the land. Now, so these lithospheric plates, these are the plates that are going to float on the magma underneath the crust, and these plates are what have the continents, and the oceans are on top of it. So these plates have both oceanic and continental crust. Okay, so these are just really big plates. There are 12 of them on the Earth, and so if you take a look at page 65, that can show you all 12. Now these plates, the smaller and lighter ones, they're going to move fast. Now fast is a relative term because in our lifetime a lot of things don't move, but you know, they move like a centimeter a year kind of thing if they're going pretty quick. But the large and heavy ones, they're going to move slow. All right, so these are relative terms. But the smaller, I mean, that should make sense. If something's small and light, it should be able to move faster. Now there's three types of boundaries between these lithospheric plates. We have a divergent, and it's not like the movie, although if you've seen it, it's an excellent movie, or at least I had fun with it. We have our divergent, also called constructive boundaries. And a divergent, they call it that because the plates are moving away from each other. These are the types of boundaries with our mid-ocean ridges. And they're constructive because what gets made at the mid-ocean ridge? Hopefully you said brand new ocean floor. All right, so these, if the plates are moving away, they are divergent or constructive boundary. Then we also have boundaries that are convergent, which we call destructive. They're moving towards each other. This is where you have things like the trenches. Okay, so you have whichever plate is more dense is going to get pushed down, and whichever plate is less dense is going to float up on top. And so that's what happens there in the trenches. We just talked about that recently. And then the third type, well, if you have one that is constructive, one that's destructive, we're also going to have one that doesn't either make new earth or new rock or destroy it, and that's called a conservative. This is called the strike slab. They just grind past each other. A lot of earthquakes happen along here. Now, take a look at page 66, and there's a picture there. I want you to look at that and ask yourself, where are the major earthquake and volcano areas? And then also ask yourself, where are the edges of these lithospheric plates? You need to think about that to be able to answer the questions. Okay? Now, why do they move? Well, the prevailing theory, okay, means it hasn't been proven, but what they think happens is the convection currents underneath in the magma cause the plates to move. So the magma cycles between hot and cold, and as it does that, it moves the plates around. So what happens when the continents collide? There's three different possibilities. You can have an ocean versus a continent, and whichever one of those plates is more dense is going to be pushed down. That was called subduction. Remember, we talked about that. And these subducted plates, these are going to melt. Now when they melt, that produces magma for volcanoes. Now the less dense plate is going to fold into mountains. So think about it. Why would these two things, why would the fact that this forms magma and this forms mountains, why would that make more volcanoes? So think about that. That's something you need for your sheet. The second possibility is two ocean plates, running against each other. Now these are going to make island arcs. That's because what happens is they form the less dense, just like up here. The less dense forms magma. The more dense forms the magma, and the less dense folds into these mountains, makes it into a volcano. These volcanoes grow up to make islands, and as the plates move, these islands form arcs, so they're called island arcs. Hawaii is an example of an island arc. And then the third possibility is we have two continents colliding. And when that happens, you're going to have basically mountain ridges formed. And that's because these continents tend to be both the same density. They both tend to be very light in comparison to the other plates. And so when they push together, they just form these huge mountain ridges, but not necessarily volcanoes. Now, page 70 and 71 are some really nice, that's nice, not Nia, some really nice pictures in your book. I'd like you to take some time and take a look at it. So hopefully between this video and your book, you're able to answer all the questions on your handout.